Okay, here is my second video about this new inverter. This is a 10 kilowatt inverter. It's all in one, everything included. It is also a split phase, that is, it allows 120 volts and 240 volts. You're allowed to have two 120 volts at anti-phase, so between them it's 240 volts, just like our city power in North America, in Canada and USA. The model that I purchased is this ASF 48. 48 means 48 battery system. 100, I'm not sure, 100 amps or something. 200 amps should be the 200 amp of battery current, I suppose. Okay, so now this is the first time I opened up the lower part. This is where you are supposed to connect the wires. The solar panel, here is the battery. This is some communication electronics. I don't know this very well yet. And on the left hand side is the AC input and AC output. So the AC input can be connected to the city power. It can also be connected to a generator. I've got a generator, a Honda generator, an old one, that can also generate split phase electricity. So we have 120 volts and two 120 volts, and between them it's like 240 volts. So you can connect those kind of a generator. You can also connect it to city power. So I will discuss that part in a future video. So the video now is about the wire size and my concern about the wire size they used. So let's start from the right side. So this is where you put in the solar panel. So you can put in two different solar panel systems. So you can see the PV1 positive, PV1 negative, PV2 negative, PV2 positive. So I'm glad that they put the two negative input terminals in the center and the two positive ones on the two sides, which is I think is better, because you don't want to make a mistake and use a negative electrode and touch the positive one. You know, when you are dealing with this huge battery system, you'll see like sparks flying everywhere, like melted metals flying everywhere, and then you can have a big piece of like copper terminal and you can have it burnt. Half of it is gone, or a portion of it is gone. So this is a good design. And the wire they used, so I try to find out what size the wire they used. So now I used my own, this is a 10 gauge wire. So I just use this to compare. So what I can see is that the wires they used here is at most 10 gauge wire. I don't have a big issue here, because if you check the wire size data, so a 10 gauge wire allows a maximum of 30 amps to pass at 60 degrees Celsius. 60 degrees Celsius is actually quite hot, because I normally use like around 40 degrees, a little bit above, maybe 41 or 42 degrees Celsius as my bathtub water. So 60 degrees is already way beyond that. So, but anyway, 30 amps. This is no problem, because they allow very high voltage solar input. So they say that anything below 500 volts is allowed on this machine. So as a result of that, they only allow a maximum of 22 amps for each one of these solar input. So 22 amps is below 30 amps that I just mentioned. So I think this wire size here is okay for a maximum of 22 amps of solar input. So now let's move to the left side. This is where you can see AC in. AC in is where the city power can come in. You know, in North America, Canada and the US, you have 4-wire system, right? A ground, a neutral, which is usually white, a black, and a red. So each one of them, black or red, they are 120 volt system, but between the two it's 240 volts because they have anti-phase. You can also hook up with a generator. I got a Honda generator that also generates split phase electricity. So you can have 2 live wires, and between them is 240 volts, but each one of them is 120 volts. So on the other side is the AC output. So it's the same thing. So you can output also a 4-wire system. So you have a ground on the right, a neutral in, and also 2 live wires. And between the two, you can have like 240 volts, which is very nice because you can hook this up with the city power, and then it will automatically switch between city power and battery power depending on the level of your battery. But the problem that I find here is the size of the wire. Okay, they also use, like, if I compare this 10 gauge wire, I think at most this wire size is 10 gauge. This is huge problem. Okay, so if you calculate, so if you are using like 10 kilowatt on one of these phase, like on a L1 or L2, that would be 10,000 divided by 120. I calculated it's something like 83 amps. I don't think in North America we'll allow to pass 83 amps in this tiny wire, like this 10 gauge wire. There's no way we allow that. So we should allow, in this case, it should be something like 4 gauge wire. So that's okay. So if you are using this only for 240 volt system, you have a better. So it's a little bit better because in that case you reduce the current by 2. Yeah. So that means it's like about 42 amps. So still 42 amps is higher than the presumed high upper limit of a 10 gauge wire. The 10 gauge wire, using 30 amps is kind of I'm not saying that it will start a fire immediately, but it's legally you're not supposed to pass 42 amps of current through a 10 gauge wire in North America, because I don't think it can pass any inspection because this is not allowed. Okay, so not only this is a big problem. So in other words, I'm very suspicious about the claim that this is a 10 kilowatt inverter, because based on my calculation, you can safely use this continuously, like 3,600 watts, maybe up to 4,000 or even 5,000 watts. I would not go anything higher than like 5,000 watts. So they claim it's a 10 kilowatt inverter, but I would only dare to use it up to like about close to 4,000 watts, because with this wire size, you're not supposed to use such a high current. Here the battery, these are the battery input. So you can see the black one is the negative, and the white one, the red one, is the positive on the right. I also measured this is a metal like a plate. So I measured the width. The width of the negative is 16 millimeter. And I also measured the thickness. The thickness is something like 2.5 millimeter. So if you calculate the cross-section area, this negative is about 1 AWG, 1 gauge wire. So if you check the 1 gauge wire table, you see that it can pass 120 amps of current at 60 degrees. But if you calculate the 10,000, like 10 kilowatt, if you're using it as a 10 kilowatt inverter, this should allow 200 amps of current to go through, because you use because the battery system, it's a 48 volt system. I just counted as 50. So you divide 10,000 by 50, you're going to get 200. So you need bigger than this. You probably need double thickness of this for this much current, close to double. And even more problem on the positive side. So on the positive side, the size of this plate and the size of the upper part near the red heat shrink is the same size as the negative, but it goes through. I think it is a switch, or it is a I don't know what it is. I think it is controlled. You can switch it off and switch it on. So they are connected by these two pieces, here and here, and these two pieces are the same width, about 16 millimeter, but they are thinner than the other one. So it's like only half of the thickness. So in other words, that reduced the current allowed here. So the current allowed here, if you calculate the cross-section area, it corresponds to a 4 gauge wire, which based on the table allows a maximum of about 70 amps. So from 70 amps to 200 amps is really a big difference. So I do not know how they can claim that they can claim that this is a 10 kilowatt inverter due to this limitation of the wire size. So I contacted them. I tried to because I feel I'm being cheated in a way, because this is not cheap. This is a relatively more expensive one. It's the most expensive one I've ever bought. It's also supposed to be the most powerful one. I have another one which is also a split phase, but it's a Taiwan product. It's this very famous MPP brand name. So that one is 66 kilowatt. So it's 6 kW machine. So this one is supposed to be a 10 kilowatt machine, but I now have strong doubts. And I'm in the process of arguing with them because I can only use this for an inverter, like a 4,000 watt inverter or a 5,000 inverter at most, because I do not believe that we can use it up to like 10,000 because of the wire size here, and also the limitation of the current from the battery is also, these two are very small. So I told them that if you want to sell products here to allow us to use it legally in our houses, and that does not void our house insurance. You're supposed to make the wires based on North American standards. Like, you're supposed to make them so that we can safely use them without any legal problem. But they say that they have tested it, it's okay, and they just insist on that. And I want some compensation because I don't want to spend $2,000 to buy a 4,000 watt inverter. I thought I was buying a 10,000 watt inverter. So that is the argument. But I think I have very little chance because the AliExpress, that's the risk you have, because when you buy things there, they most likely would protect the sellers, not the buyers. Okay, that's all for today. Thank you for watching it, and if you like it, give me a thumb up. Thank you very much.